Now let's get back to the exercise and let us try to write up some kind of solution to this thing. Okay, so the setup was we had a real random variable x, and we understand what that means now. We assumed that we had a sequence of real numbers that tended towards 0, and we then defined a sequence of real valued random variables xn by multiplying each of the numbers in the sequence onto x. And now we want to show that this sequence of real random variables that we have created, xn, tends almost surely towards 0. Now, intuitively, we have a feeling that because an goes towards 0, then xn should probably also go towards 0, because we're multiplying something that goes towards 0 onto x. However, we will need to, there needs to be an infinity here. I don't know why it disappeared. However, we will need to show this rigorously. And for that, we will need to use the definition. So we want to show that xn goes almost surely towards 0. This means that by definition, we want to show that the probability of xn going towards 0 is equal to 1, right? This is the definition of almost sure convergence. The probability of xn going towards 0 as n goes to infinity is equal to 1. Okay, this means we would like to show because let's just think about this for a second. What is xn exactly? Let us just plug in what xn is. So we would like to show that the probability of an multiplied by x going towards 0 as n goes towards infinity is equal to 1. And more specifically, if we consider again the definition of almost sure convergence, we had this thing that we wanted, that we realized that almost sure convergence is something that is defined like almost omega by omega. If you can gather all of the omega on which the convergence holds, and that set of all of these omega has full probability, then you have almost sure convergence. So we would like to look at how a in x behaves for each omega. Okay, this is like more or less the strategy that we're going to work with, and with no guarantee of this actually working, let us just try. Because we're kind of in the basics right now. Later on, you guys will get loads and loads and loads of tools to show almost sure convergence of things. Depending on which thing you're looking at, the result of almost sure convergence towards something can be everything between totally trivial results to totally profound results. But right now we're just working with the definition. So let's just look at how an multiplied by x behaves for each omega. So what do we say? Well, I can say set, let us set omega in our probability space. Then how does an of omega, an multiplied by x of omega behave? Well, then we can notice that that an multiplied by x of omega, well, this is just a real number, right? I mean, an is a real number, and x of omega is just a real number. We've taken all the functional mystery out of it by setting an explicit omega. Okay, now, what does this go towards, as n goes towards infinity? Well, by definition, an is a sequence that goes towards 0. So we have a 0 here. And x of omega does not depend on n, so it just goes towards x of omega. So this product goes towards 0 multiplied by something, and what that something is doesn't matter because it just goes towards 0. And this is a nice thing, because what we have shown now is, given any omega in our probability space, an multiplied by x of omega is equal to 0. So, hence, we can see that no matter which omega we choose, in our probability space, we will always have that an multiplied by x of omega goes towards 0 as n tends to infinity. So this means that if I'm considering my probability space omega fp, then if I choose this omega, everything will go towards 0. If I choose this omega, everything will go towards 0. This one, this one, this one, this one, this one, every omega that I choose. Which actually also means that the set on which an multiplied by x goes towards 0, well, that set is just the entire probability space. So, hence, an multiplied by x goes towards 0. This event is just the entire probability space. Wow, that was nice. And that is nice because, well, it means that the probability that an multiplied by x goes towards 0 is equal to 1. And now we have shown that xn goes almost surely towards 0. Before we end this, there is kind of a leap of logic here when I go from here to here. And it pays to spend a little bit of time thinking about this. I know that we're spending a lot of time right now digging inside what seems like a very, very simple exercise. But a lot of the strategical points, they are made in these really simple exercises. So we said that no matter which omega we choose, we will always have that this happens. What does this actually mean from a logical standpoint? Okay, so what does this mean from a logical viewpoint? I want to kind of make this point here. I do not know what just happened there. Let's see. Okay. So this is kind of taking all the mystery out of how I do my colors and stuff. So, but yeah, I have to learn how to control this mouse. Okay, so what were we talking about? How did I go from this? Hence, we can see that no matter which omega we choose, we will always have that an multiplied by x of omega goes towards 0. How do we go from there to concluding that that means that this event and this event are similar? There is a kind of a small nuance there that I think is really important for us to grasp. I will do that in the next video because this one is becoming a bit long. See you there.